Assalamualaikum everyone. Today we are going to talk about system of linear equation, which is solving problems using Gauss-Jordon elimination and free variables. So before we start, our group name is Powerpuff Girl. Course code is MAT263 and program code is CDCS1124B. So before we start, let us introduce ourselves. We are Nurel Arfa binti MAT263. Student ID is 2022817132. Second, Nur Allisya Iman binti Muhammad Asri. Student ID is 2022816332. And lastly, Nur Azmanina binti Azman. Student ID is 2022483078. Now, let's get started with the introduction. A farmland requires 15,250 units of mineral A, 100,000 units of mineral B, and 37,000 units of mineral C. There are three types of fertilizer that the farmer use, which is fertilizer 1 contain of 2.5 units of mineral A, 40 units of mineral B, and 10 units of mineral C. While fertilizer 2 contains of 5 units of mineral A, 50 units of mineral B, and 15 units of mineral C. While fertilizer 3 contains of 10 units of mineral A, 10 units of mineral B2, and 15 units of mineral C. So the problem is, how many bags of each fertilizer should the farmer use to attain the required amount of minerals? Before we go to the calculation, we must know the purpose of the study. So, the purpose of the study is firstly, in order to help farmer to determine how many bags of each fertilizer should the farmer use to attain the required amount of minerals. Secondly, formulate and solve a system of linear equations. And lastly, to use the Gauss-Jordon elimination method to solve the problems. That's all.
Let's move to the methodology. To determine the number of bags of each type of fertilizer need to meet the mineral requirement of a farmland, we first set out a system of linear equation based on the given data. Let X represent the number of bags of fertilizer 1, Y represent the number of bags of fertilizer 2, and Z represent the number of bags of fertilizer 3. Then derive the equation from the mineral content of each fertilizer and the total required amount, which is 2.5x plus 5y plus 10z equals to 15,250 for mineral A, 40x plus 50y plus 10z equals to 10,000 for mineral B, and 10x plus 15y plus 15z equals to 37,000 for mineral C. We then convert this equation into an augmented matrix and use the Gauss-Jordon elimination method to simplify it. The process begins by normalizing the first row to create a leading one, followed by eliminating the first column elements in the other rows using appropriate multiples of the first row. Next, the second row is normalized to introduce another leading one, and elements in the second column of the other rows are eliminated accordingly. This process is continued until each leading one is the only non-zero entry in each column, resulting in a matrix in reduced row echelon form. This form reveals that the system has infinitely many solutions. Then we express x and y in terms of z. Let z equals to t is a free variable. Hence, the general solution is x equals to 60 minus 3,500, y equals to negative 5t plus 4,800, and z equals to t, where t can be any real number.
For the this question, the result is z equals to t, x equal to 60 minus 3,500, y equals to 4,800 minus 5t, where x represents fertilizer 1, y represents fertilizer 2, and z represents fertilizer 3. By using Gauss-Jordon elimination method, we can determine the number of bags of each type of fertilizer needed to be meet the mineral requirement of the farmland. A planned quantity of 15,250 units of mineral A, 100,000 units of mineral B, and 37,000 units of mineral C are needed for the farming. We have shown that the Gauss-Jordon elimination method allows us to calculate how many bags of each sort of fertilizer are needed to get the farmland's desired mineral composition. Decision-making flexibility based on extra limitation such as availability and cost is provided by this technique. For your information, to ensure realistic and non-negative value for the number of fertilizer bags, T must be any real number within the range of 584 to 960. This range is critical to maintaining the feasibility of solution, ensuring that the calculated number of bags does not result in negative quantity, which are impractical in real-world application. Okay, now for the conclusion. We have two conclusions. The first one is the purpose of this study was to calculate how many bags of each type of fertilizer would be required to meet the mineral requirement of the area. We took the necessary amounts of minerals A, B, and C into consideration using the Gauss-Jordon elimination method. The second one is by using mathematics. This technique guarantees that the farmer's choices are based in quantitative analysis and offer flexible and practical solution. The parameterized method maximizes the performance of farms and efficiently uses resources by providing a variety of fertilizer combination while guaranteeing realistic and non-negative values. That's all from us. Thank you so much for watching.